Hey everybody, how's it going? And welcome to part 3 of our YouTube tutorial series. So if you've been sticking with me, congratulations. That was a lot of code for the assembly portion, but we're kind of out of the woods because these next 3 YouTube tutorial series are going to be more kind of open-ended. You're gonna have more kind of control over the code, whereas the last 2 videos you were kind of just um, typing in glad functions and setting up, assembling the project. So now we're actually going to be doing some cool stuff. All right, so if you are just joining us, like you just started here, you're an advanced OpenGL programmer. We're going to start uh, with the Learn OpenGL Victor Gordon tutorial. We're going to start with his template at, it was OpenGL 8 camera. So I'll be linking that template code in the description. But we just, in the last 2 videos, we just spent building an identical code to what the Learn OpenGL is. So we're just going to work with, we're going to work from there and then hopefully get some blocks loading. So without further ado, let's get started. All right. So let's open our project. So after this right here, or maybe after the viewport, doesn't really matter. We're gonna add the depth test. And we're gonna see if it works. So hopefully this tutorial can be more open-ended, and we can kind of go through any errors that we see. That would be nice. And then what we have to do is we have to clear the depth buffer every frame. So let's go into here. GL depth buffer bit. Cool. So we just do the depth test and then we clear it every frame. So let's go ahead and run that and see if it does anything for us. Oh, it looks like it worked. Cool. So that's how you add depth testing. And all right. So if you are joining us from the Learn OpenGL, if you're an advanced programmer, I want you to go into this camera C++ file and just change the speed from 0.4 to 0.004. This will help you slow down because you go really, really fast when you run your program. So that's one change I would make from the code. All right, so without further ado, let's get started with the block. Okay, so like I said, this is going to be more of a educational tutorial video. I'm going to try to be more, I guess, open-ended because we have our code all set up, and now we need to start, visualizing what we're going to do. So, when I was at this point, I got really stuck. I didn't really know where I would go from here because all this was very confusing. I didn't really understand it all. So, I mean, one of my first ideas was to do instancing, so we can kind of like check that out, just so I can show you how it works, because I think we'll see if I know how to do it. So basically, this GL draw elements function, we're gonna add instance at the end of it, and then we're gonna add how many times we're gonna call it. So let's do it like 10. So we're gonna do 10 instances of our GL draw call. All right, and then all we need to do is go into this default vert and this GL position right here. Well, I believe we'll need to import the model actually as well. So let me see if we even have a model. We don't, so we'll get to that. We'll get to that in a bit, but anyways, what I wanted to say was that instancing is not a great option. We can't really do it right now because we need to have the model set up. So let me see if we could just get that going. Let's see. Yeah, let's just try it actually, because we're here. We can kind of be more open-ended. Yeah, so we're probably going to want to initialize the matrix. Probably right here. Let's do it outside of the while loop. Just see what we're doing. And we might need it in the while loop because it's the model. Yeah, let's just do it in the model. No, okay. And then we will pass it to the vertex shader. And so yeah, we won't. We can take this out. We don't need this in the while loop. We can do it outside the while loop. And then one of my cats turn on the fan. Turn it back off. Okay. So we're just initializing a matrix model, and then we're gonna get the GL get uniform location. Shader program ID and model. Okay. And then for this let's see if we can do this. I know we do one of these in the while loop. I'm not sure which one it is. Okay, that look good. All right, so hopefully that's correct, and let's go into our vert. Okay, so now we can also take a uniform, assuming we did everything right, model, and we can multiply the model by the camera matrix, and then what we want to do all right, so we added X, Y, and Z. And what we want to do is we're going to go back to main. Let's turn this back to instance just to see if it works. Do 10, and then we'll go into the vertex shader, and we will multiply the X position by GL instance ID. I think it's ID. GL instance ID. Let's try it. It might be GL instance. Well, we'll find out. Ooh, we ran into some errors. Let's see what we did wrong. Okay, so what we're gonna do, we're gonna actually add a underscore to this GL instance ID. I forgot that, and then we actually want to add it. We don't want to multiply it, so let's try that. See if it works out. Okay, it worked. Cool. So let's zoom in. All right. So I just kind of want you to visualize what's going on. We basically just made 10 instances of the triangle. So this is kind of a way you can visualize what you're trying to do with the voxel engine, but you're actually going to learn that instancing is not very efficient. And once you get to drawing multiple, millions of blocks, it'll really slow down your computer. So instancing is not the way we want to go. So I'm glad I was able to show you this, but we're not going to do instancing. So let's go back. Let's just redo everything. Okay. We can keep model because we might need that later. We just need to go into draw elements instance. Let's change that back to draw elements. And let's remove the 10. All right, so that was instancing. So let me make sure I'm still recording. Yeah. So what we're gonna do is sort of instead of instancing, we're gonna do something. I think it's similar to like batch rendering, but I don't really know. What we're gonna do is we have to kind of visualize what we're trying to do. We have this array of vertices, and we can't really change the size of it. So if we add more vertices, we'll have more sides. So how do we get it to where we can kind of manipulate it? And that's what I'm going to show you today. So we're going to go into this VBO, and we're going to include a vector, or the vector syntax for C++. A little different than a vector from GLM, but yeah. Okay, and in our VBO, we're going to initialize a struct vertex. And it's going to have GL float position. And then we're going to skip color because we don't need color for a voxel engine. All right, so now we have a struct, and it basically creates three positions and 2 text chords. And then what we're going to do is change the VBO constructor. So instead of taking vertices and size, we're just going to take that's vertex actually. Vertex. Vertices. Vertex. Reference. Vertices. Alright. So now we have that all changed up. We're going to go into our VBO C++. Do similar changes. So instead of taking this argument, we're going to do the same. So we go into VBO.h. We can just copy this big old thing and put it in VBO. Oops. Boom. All right, and then size and vertices we got to change. So size is going to change to the vertices dot size times size of vertex, right? Vertex. And let me make sure this is like that. And then for the second argument, we're just going to do vertices dot data. So this kind of simplifies. We don't really need to take a size because we just go into the vertex and we see there's 5 floats, so that's going to be the size of the vertices. So we just do vertices-data. And then also, yeah, same thing over here. We just multiply it by the size of vertex. So we get all the information from the vertex thing. All right, and then we just do the same in the EBO. So real simple, go into EBO header. Right here, this EBO, we're gonna grab that. And we're gonna change it. Oh, we need to include the vector. All right, yeah, let's change this EBO. So taking the GLU int pointer, we are going to do std : vector. It's going to be an unsigned int. That's the type for indices, because they're just numbers. And we also want to do a reference to it, and do indices. Okay, that looks good. Yeah. All right, so then we just take this. We're going to copy it. Oops. And you can probably guess, we're going to put it in the C++ file for the EBO. EBO right here. Copy paste. Cool. And then for size and indices, the size is going to be indices dot size times size of, I think it's just unsigned int. And then so indices, we're going to do indices dot data. See, so now everything's kind of simple with all the things that we need. So cool. All right. And so outside of main, so we're going to go back to the main function. Let's do that. We got an error. Yeah, that makes sense. Okay, so outside of main, so right here, actually, we are going to do some data. So std vector vertex. And I think we need to, nope, we don't need to include anything. Vertex vertices. And then we'll do indices. And make sure to change this to an unsigned int. Cool, we have vertices and we have indices. Okay. So in main, we can actually get rid of these. Well, we can keep the indices for now. But we don't really need them right now, so. Let's see what we can do. So let's do the pushback in main. We're going to push back some vertices. And I believe we do this after. We don't need to because it's just the vertices. We're just interacting with the vector. So let's do it before. All the VAO stuff. Yeah, let's do it. Okay, so we're just going to push back some values to the vertices. That way we can figure out if it's working or not. So vertices dot push back. And the goal is to fill the vertices with vertex coordinates. And we're just going to keep filling it and construct like a mesh where we have this giant chunk of blocks, and we're all going to do it in one draw call. So I'm going to show you how to do that. Negative 1.0f. 1.0f. Okay. So we'll take this pushback and we'll do it 4 times. 1, 2, and we're going to do positive for the last 2. We're going to do negative for all 4. Negative for the middle 2, but positive on those. And then do okay, so we're pushing back the vertices. And so we're just constructing a just a real simple double triangle. So we just need we only need 6 indices. So yeah, we can still give me 1 sec. We also need to add the stride, so let's do that. This link attrib thing, it has to be changed. So we're gonna get rid of the color. We're gonna change this to 1, 2. And then we're gonna set the stride 5 times size of float. Okay, and then instead of this, we're just gonna call it stride. Stride. Okay, and then we can just change this to 3 for now. All right, and then so for this right here, we don't need the size of vertices anymore. We just need vertices. So it makes it super simple. And yeah, this is just indices. If it wants to work. Okay, so yeah, we need to let's get that going. I think we just get rid of this, right? Yeah. So let's push back, since we got rid of that, let's push back the indices as well. There you go. And we can just push back single numbers like this. This might be easier to look at, you know? All right, and we just need 6 indices, so 0, 1, 2, 0, 2, 3. All right, cool. And then what we need to do is we need to update the vertex and the fragment shader. Let's do that. We don't have a color anymore. Just have a text. Get rid of a color. Keep the text. And fragment, do we need to change anything? Just get rid of this color. Your kitty's okay. Alright. Cats are doing something. Alright, so now we have the fragment and vertex shader. Last thing we need to do is we need to go to this size right here. Instead of 18, we need to do GL size I indices dot size. Okay, so that's how we're going to calculate the size of the indices for the draw elements. So let's just see what we got. I think I got everything. Sorry for the delays and whatnot. Let's roll it. Okay, everything worked. So we have our one block. We're just doing one block right now. All right, awesome. So now that we have our block, yeah, I'm happy that worked out. Or sorry, now that we have our square, we could build a block. So the way we build a block is we just take this and we'd multiply it by 6. So I should probably do that for the tutorial. So let me just do that. So let me count 1, 2, 3, 4, 5, 6. Okay, so we have 6 sides, and we just need to do a different indices for each side. So since we're doing it all in one, we have to go up by 1 for each indices. So 0, 1, 2, 0, 2, 3, 4, 5, 6, 4, 6, 7. So the reason indices go like this is because we're doing like one triangle and then we're doing another triangle. So if it's 0, 1, 2, 3, you do the 0, 1, 2, and then you go 0, 2, 3. That's how you build the square out of 2 triangles. You use the indices. Cool. All right. So 4, 5, 6, 4, 6, 7, 8, 9, 10, 8, 10, 11, 12, 13, 14, 12, 14, 15, 16, 17, 18, 16, 18, 19, 20, 21, 22, 20, 22, 23. All right, we got that. Now we need to go through here and do every side. So we did, like I said, the way OpenGL draws triangles. So it's -1, -1, 1. So like I was saying, the first one is left, so it goes that way. Then Y is down, it goes down, and then front, because it's positive for the Z. Instead of back, it goes front, so it goes that way. So that's where the first point is, and then we do that for the bottom 4. So we just need to do this now. Instead of the bottom, we need to go left, back, right, front, and then top. So let's just do that right now. Left, it's going to be all negative. Negative, positive, negative. Negative, positive, positive. Negative, negative, positive. Okay, that's done. 1, negative, negative. 1, 1, negative, negative, 1, negative, 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 negative. 1, negative, 1, 1, 1, 1, 1, 1, 1, negative 1, 1, negative 1, negative 1. All right, almost done. Negative 1, negative 1, 1, negative 1, 1, 1, 1. 1, negative 1, 1. 1, 1, 1, 1, negative 1, 1, 1, negative 1, 1, 1, 1. All right. So let's see if we have a block. Look at that. We have a beautiful block. Everything's working, and I'm happy for that. Okay, so this looks good. So, all right, we have one block. how do we build a whole bunch of them? You know, how do we build 4,096 blocks? Well, we will get to that. And if you're an advanced, you know, OpenGL programmer, you can kind of already get the idea of what we're doing. But yeah, this is kind of how we do it. So we're just gonna build a for loop. So outside of main, give me 1 sec. And we might actually have to do this in main. So, oops. But here's a great place to put it. So we're going to do void rebuild mesh. And this is just a simple function. And if it doesn't let me do it, then we can do it outside of main. And it looks like it's not letting me. Let's do it outside of main. Okay. So for int. Let my cats out. Int equals 0. Now my dog's coming, so sorry about that. All right. So this is a simple for loop, and we're just doing it up to 16 since we're doing a 16 blocks per, 16 by 16 by 16. So. And I guess we can just do 1 so we can kind of figure out, hey, what are we doing? Because we're going to take this pushback. Let's just do 1 for now. We can do the rest later. Okay. So we'll do the pushback, and then for, we can kind of close this out for now. We're just going to comment this out while we work on this. We might go back to it since we have the thing. All right. Sorry. So yeah, you can kind of get the idea. We're just going to add X to each all right. And then we had to include an offset, I believe. Oh, and we need them floats. So let's do that first. Okay. So fx equals float x. Let's do that. So I'm going to put the floats in. Oops. Fy fz. But I guess we don't need these right now. We can just kind of close them. All right, and then we'll do fx. All right, and I believe to yeah. So we're gonna do an offset. So let's do that. Unsigned int. So for each time we iterate through x, we have to for each for each square we have to add 6 indices. So that's what we got to do. All right, so here's the offset. It just takes the vertices size and it adds it to whatever we need. So right here, we're just going to do offset plus 0. Just copy that. Zero, 1, 2, 0, 2, 3. Okay, so we're pushing back to indices. We're adding more vertices for index. Okay, cool. That looks good. And now all we need to do is test it. So, are we missing anything? I believe we are. We just need to call rebuild in the in main. I don't think we call rebuild in. Let's do that. Rebuild mesh. All right, so now we're calling our function. So we're doing all the pushbacks. Let's see what happens. All right, so it looks great. We're just kind of scrunched up, and I know why. But everything works, and everything looks good. All right, so just a couple quick fixes. We're going to put this shader program above this uniform matrix just for ordering. That'll help. And then what we're going to do is we're going to fix our errors. And since it was squished, the reason was because we were doing -1 to 1. So if we just do 0 to 1, that'll fix it. So let's just do that. Okay, let's try that out. All right, so there's our line of squares. So this is perfect. We're doing this all in one draw call. So you can kind of put the dots together and figure out what we're going to do. We're going to make blocks, and we're going to do it for, we're going to make a lot of them. So let's just do that right now. All right. So we'll do Y and Z. All right, that's good. And we'll multiply this. Okay, and for the Y, we'll do FY. And then alrighty, cool. And we're missing something. What are we missing? 1, 2, 3. 1, 2, 3. Does that look good? All right. So we just multiplied it by 2 dimensions, and then we're just gonna add these. Let's roll it. Let's see what happens. All right. So if you're looking at my screen, this is kind of what we wanted. Now it's starting to look like a product, you know. So looks really good, and we can kind of go inside and kind of see what's going on in here. Cool. All right. So this is our chunk, I guess, and we're just gonna make it into blocks. So let's do that. The final step is we are just going to multiply this by 6, and we can kind of just take, see how this, we just took this, take this whole function. Well, it might actually be easier just because we have the fx stuff. Might just be easier to do this. 4, 5, 6. Because, yeah, and then we just go through this whole thing. Actually, I don't think it'd be easier. Let's do the other way. We'll go the other way. Okay. Re-add the parentheses. Cool. Let's do it the other way. Let's just take this whole block and we'll go through and we'll add fx to it. All right, we got vertices pushed back. So for all the indices, we have to do offset plus. So we can kind of we'll just go through and copy paste this in there. Oops. All right, so we got the indices all fixed up. Now let's do the vertices. So we have them all in the right spot. We just have to, instead of the negatives, we just do fx. I guess we could just run through fx first. That way it might be easier. This will just all be fx. This is annoying. Sorry. Kind of burn through these. Nope, I don't want to do that. Probably fx, I could just copy that. Okay. Good. Okay. Okay, now let's do y and then we'll do z. Fy. Oops, did the wrong one right here. See that? The wrong one. That happens. Okay. So 1.0. Okay, looks better. All right, now we're doing Z, and after this, we should be able to get our block. So just bear with me. This is an error. I need to do FZ, FY. All right, we got an error. This is the back. This should be negative. Negative. Back. Left. Oh, this is left. Nope, no error. Sorry. Okay. Okay. Is that right? Yeah, it looks right. Okay. Yeah, a little bit of errors, but all right, one more. All right, so we've added the XYZ for all the vertices. Let's run it. See if we got any errors. Wow, looks really good. All right, no errors. We have a, oops, sorry. We have a chunk, and it looks great. So, and I believe if we zoom out, you can kind of see the, I don't know if the mid maps are on, but yeah, it just looks good. So now we have a huge 4,096 blocks. So yeah, thanks for watching this tutorial. In the next tutorial, we will be, oops, sorry. Maybe my screen is broken, but in the next tutorial, we will be doing the chunks. So thanks for watching.